Hello, and welcome to this OpenTopography tutorial. My name is Chelsea Scott. This video will look at topographic profiles, specifically looking at natural areas. And I will show you how to compute and visualize topographic profiles and discuss why we should look at topographic profiles. So to start, what is a topographic profile? So here we see a topographic hillshade or shaded relief map along a landslide in Central California. And we can see a lot of details about this feature from this topographic hillshade. But we can also make a topographic profile to learn more about the shape of the feature. And here we're seeing at the bottom, this is a topographic profile, which is plotting elevation versus distance. And then this red line that we see is the elevation of the Earth's landscape across this line. And we can learn really a lot more about the landscape with this topographic profile along with the topographic hillshade, as you can really nicely see changes in slope, which can indicate the process that guides this area. So let's discuss in more detail why we should compute topographic profiles. So specifically for digital elevation models, topographic profiles are really useful for visualizing landforms in cross-section. So in particular, we can really see the relief and the steepness of an area. We can also see the feature shape, which can give us more information about what the shape or about what the feature represents. And at a higher level, this helps us to identify geomorphic landforms, such as fault scarps, cliff crests, terraces, and channels, which again can give us more information about the surface processes that have built the landscape. And finally, we can compare slope characteristics. For example, see where the slope is concave versus convex, and see local changes in steepness. And this can indicate the local processes that are active in that landscape. You can also make profiles across maps of vertical change. For example, this is helpful to really nicely be able to quantify change. As I'll show you, we can then better see the change in elevation from a landslide. And this can add more information than looking in map view or clicking on individual points when you're interested in quantifying that change. And you can also see how landforms change. For example, following a landslide, we can see how much the cliff retreated, which is a very important metric of the landslide. We can also look at changes in steepness, which may indicate future behavior of that area. So shortly we'll be looking at some some topographic hillshades and DEMs of the Mud Creek landslide that occurred in Central California along the coastline. We'll be looking at two data sets. The earlier data set, sometimes called COMPARE in differencing literature, is the USGS LiDAR point cloud from the West Coast El Nino data set. And this was collected in March to April 2016 and has 11 points per square meter. The second data set, called reference in the differencing literature, is a California FEMA data set. And this was collected in January through April 2018 with 6 points per square meter. So there's roughly 2 years separation between these data sets. And it's an interesting case where the reference data set actually has a lower point density than the compare data set. So now we are in QGIS, and I have preloaded the results of vertical differencing calculated on OpenTopography, and then I calculated the topographic hillshades in QGIS. And we do have videos that I welcome you to reference to see how to do this. So, but now we're focused on the profile tool. So to open it, we have to install it first. So you want to go to Plugins, Manage and Install Plugins. And then you'll want to go to All up here and type in Profile Tool. Double click it here, which will then load. It was already loaded for me because I was looking at it earlier. And then you can say install plugin. And there we go, it's now installed. So there's a few ways that you can then access that plugin. One of them is to come up here back to plugins, come down to profile tool, and say terrain profile. And when we do that, the bottom of our screen becomes the profile tool. And the first thing we want to do is add the data sets that we want to see the profiles of. And that's going to be the reference and compare DEM. So the output.reference layer here is that reference digital elevation model. So I want to highlight the layer and then come over here and say add layer. And then we'll want to do the same for the compare. So I want to highlight the compare layer and come here and say add layer. Now they're both going to be in red to make it hard to differentiate them. So let's change the reference to be the compare or to be blue. So we'll double click the red and then we can select a new color and say okay. All right, so now we're going to make a profile looking at these two data sets. So then when I put my mouse on the screen, I have that cross, as you can see in the central part of the hillshade along the coastline. So then we can draw where we want that topographic profile to be. So to draw it, you make a first click, and now I can decide where it can be next by moving the mouse. Say I want it to go up here. And then I can draw a second point. I can actually choose in any direction. Doesn't need to be along the same line. So put it just a tiny bit higher. And then when we are done, I can just either on a Mac do control click or on Windows do right click. So here is the topographic profile. So the red is the reference, or the red is the compare, and the blue is the reference. And so where the red is higher, that meant the landscape was higher on the first date. And so this is where the area had erosion during the landslide. And one thing that we can see by looking at these profiles is the change in shape of the landscape during the landslide. So if we look at the compare, so the red, which is the before, we can see the headscarp of the landslide is around here at x equals 463 meters along our profile. And then after the landslide, the headscarp of the reference is at 401 meters. So that was a lateral retreat of the headscarp of the landslide by almost 40 meters. We can also display the vertical differencing in the topographic profile. So we want to come here and we actually first look at vertical differencing. So here we have the vertical differencing results, and red indicates downward motion of the Earth's surface during the landslide. And so that's up here where we had erosion. Blue indicates upward motion. That is where there was deposition. And then to add that layer to see the topographic profile, we'll highlight it and then come down here and say add layer. It is in red, so it's not all that clear to see, but we can change it to be in green or whatever other color you would prefer. All right, so there we have our vertical differencing, and where the green is above zero, so in this area, that's where there was deposition during the landslide. Where it's negative, that's where there is erosion. And then where it's roughly zero, that is where there was no change. Now, sometimes when you load in a profile, you're going to have a few higher low points that really skew the results and make it hard to zoom in and see what's happening. So you can always come in and change the minimum axes, for example, This could be 300. And that then zoomed us in a little bit to better highlight the exact areas of our landslide. If you would like to export this plot, you can come here to say the output file you would like. So the default is PNG, but you have the other options that are there to export this information. So you can select the data type and then say save as, and that will give you options to save your data, your profile or your data. You can also make the information or the elevation or vertical change into a shapefile. So to do that, you'll go here to table, and then you'll want to say create temporary layer. And when I did that, QGIS generated these dots along the topographic profile. And these dots are going to have the information of that layer that I selected. So they're going to have the information within the reference dot band. And you zoom in, and then you can click the information and see them. And it's that value attribute. That's going to be the information of whatever raster you used to make this shapefile with point geometry. And so you can then export that by going to here and say export save feature as, and then you have the ability to save the elevations or differencing results along that profile for either later use in QGIS or use for different software. So thank you, and this concludes our video on looking at topographic profiles to look at natural areas. Thank you.